This is the more exotic stuff. So we got polymagnets, correlated magnetics research. Now, this is an image of some of their coded magnets. And what they have is a process, which is still a semi-standard process electrically, but it's an exotic new way of making magnets. And they put these magnetic dots onto one material, and these dots are called maxils, like magnetic pixels. And I was one of the first people back in 2010 or 11 to get these magnets when they offered them in their original kits. And I made this video called Geometrically Coded Magnets Behave Differently. And they have these codes on one side, they have an inverse code on the other side, and even though the magnet wants to attract, it will repel at the last second. So these little dots of magnetism want to repel, but the overall magnet wants to attract, so that meets an equilibrium where there's a little gap. You could use those for like cabinet doors that don't slam shut, or toilet seats that don't slam shut. You could use it for bed, the feet of bed, so it's hovering over the ground, so you don't have them squeak. They have over 80 or now over 100 patents having to do with these lock magnets. You can use them as locks, and there's just all different types of patterns that you can encode onto these materials, which will result in different behaviors. And I put together another video on YouTube where you can see these magnetic field tests, and I'm comparing the regular axial magnets with these coded magnets and radial, and just getting a feel for them and having other people see the differences, on a magnetic viewing film, and how they react with the iron particles, because I just love magnets. Want people to understand their awesome nature. And I was looking into how are they making these coded magnets. So I wanted to try to make them myself. And what I did here is I put together 19 nails, wrapped coils in a hexagonal grid, and I drilled holes in a piece of plastic and tried to make them as even as possible. Connected all the red ones together, connected all the blue ones together, and wanted to see if I can magnetize a piece of metal with it and have these little squiggly lines, little magnetic waves. See if I could code a pattern onto a magnetic material. And I attempted it about 8 times, different ways, going through the information that was available. Not quite been able to do it because I didn't have the amount of power, and turns out I was using the wrong side of the nails. Should have used the sharp side. But I did influence other people to start studying this concept. And what you can see is I force together these magnets that want to repel, and I have them in this grid, and then I put the nails together, and then I hit it with electricity from just a regular car battery, but it didn't seem to do exactly what I wanted. And this is what the type of stuff that they're doing. This video is by Correlated Magnetics Research, CMR, now known as polymagnets, and they have what's called a mag printer, and it's a different form of magnetization. Still use the same conventional power, but instead of making a magnet just north and south, what they're doing is they're using a 2mm print head, and they're blasting a specific spot localized on the magnet to make a little dot. And I re-uploaded their videos so people can get context on the difference between these things. And here is a list of almost 100 of their patents, which I still have, and was just reading through them. They have a lot of interesting stuff with locks and space docking. Really interesting stuff. Let's see here. Go to the next one. This is Devin from, let's see, the Mind-Blowing Magnets, and he went to the polymagnets and filmed this in Huntsville, Alabama. This is from Smarter Every Day on YouTube. And just a moment here. And what he did is he went there and filmed these examples of their coated magnets in person. The president has also visited their facility since then, and they have become a lot more well-known now. But still, people don't know about coated magnets. And when I uploaded my video in 2012, I was fighting with people online. They didn't believe in coated magnets, and they're fighting with me, saying it's a hoax. And now what? Now it's can't deny the results. So this is a really interesting company now, and they're becoming more well-known. So brings us to Tom Vallone and Integrity Research Institute. Now, Tom Vallone is talking about magnetic motors and magnetic gradients. Now, before, people are trying to use a bunch of different magnets, forcing them together in different ways, trying to make a magnetic motor spin and keep it spinning, which is very difficult, apparently, and I haven't seen anybody do that. Maybe Muammar Yildiz is a contender, but for the most part, you can't just make something spin with magnets forced together. But people have tried, and one area of science that is untapped is magnetic gradients, where you have different strengths of magnets on a material and going in a wave. And that's what these V-gate magnet motors are trying to do. And there are people trying to make these things and now trying to outsource these companies, trying to make these magnetic dots on materials in specific ways, and trying to do the old ideas of magnetic motors where you were trying to force together all these magnets, but now you can do it on one material. So uploading all of these videos and trying to duplicate these magnets for myself, I influenced a couple friends, Russ Grease of RWG Research and Electro1662 on YouTube. Now what they did is they had a little better setup than I did, rather than just a car battery, and they were able to actually duplicate CMR's process and imprint some dots onto a material. And you can see that on this videos on this next slide by Electro and Russ Grease also. And, there's a problem though, because this is still a standard process, and the dots of magnetism and those little maxils are still subject to certain laws. And to give you some context to that law, this is Ernst Abbe. And an Abbe limit has to do with lasers, like when you're point a laser beam at a wall, or you're trying to make a CD or a DVD, burning it with a laser. The diameter of the laser can only be so small. You can't go smaller than the wavelength of the light of the laser that you're using itself. So there are tricks to get around that, and there was a article by Gizmodo which shows that you can fit, almost a petabyte. That's like 1,000 terabytes of information on one disk. But you can't do that with a normal laser because the laser's dot is only so big. If you want a smaller dot, they had to have a trick where they're using 2 laser beams to focus, and then that focal point will make a smaller dot. Similar concept as what CMR is doing with their magnets. You could only wrap a coil so small. If they want to make a certain size and intensity maxil, then they have to have a certain metal core. They have to wrap that coil and hit it with a certain current. Now, in order to make that, you have to have a certain strength of current go through the wire, but the wire itself better handle the strength of the current. So you can only wrap a coil so small if you want to make that maxil. So you're limited to the amount of maxils that you could fit on a material, and you're limited to the amount of strength that they can have. It's still an advancement, but there's a limit to how many things you can fit on that substrate, which is like Moore's law, which has to do with the amount of transistors that you can fit. And Moore's law says that the amount of transistors doubles every year, every so often, until you're going to have to go smaller and smaller and smaller, at which point you're going into the quantum realm by the year 2020 or so, and you're going to have to figure out a different way of doing things, because you can't go smaller than a certain amount. Just like this process of imprinting maxills, you can't go smaller than a certain amount. But what if there was a way to imprint an actual waveform into a metal? Not dots and polarities. You're not trying to force together magnets, but you're actually magnetizing a frequency into a magnet. Now, this is a very different concept. And this is one of the most interesting things to me that I've come across in this this journey. Let me get to it here. Now imagine, as an analogy, cymatics with magnetics, or imprinting an electric signature or waveform into a metal. Now I'm not talking about imprinting maxills, but rather making a material that's finely tuned, and you're finessing it, like making a tuning fork. Something only one man has explored. Everything magnetic related, I think this is one of the most fantastic concepts, one of my favorite out of this presentation. And this is about magnetic waveforms. And all of the examples of magnets, they're all made using the same high capacitive discharge, like hammering the metal with a current just to saturate it and get a magnet. Nobody pays attention to the frequencies used, the timings, and so many other factors. It's like people have argued as if to say we've discovered everything and there's nothing else to know about magnets, and to just read a physics book because there's nothing else going on. No, but for some concepts we don't have the luxury of Google or looking in a library or even asking a peer. When you have a new concept, a new idea, there is nobody to turn to. You have to explore it, and you have to investigate it yourself. But you have to have the resources to do so. But when it comes to magnetic waveforms, the only place to turn is through R&D and experimentation. And in San Diego, California, we are doing just that. We're leading the uncharted science of studying these magnetic waveforms, a completely revolutionary approach to magnetization. And this follows the work of John Searle. Now, whenever you're looking into something controversial, you have to look at from different ways. And I put this chart together so that people can get a concept of how important things are to look into or not look into. So there are 4 options and 4 scenarios. Something is true, something is not true. You try something or you don't try. If something is true and you try, you might actually succeed. You can discover something revolutionary and beneficial. You could create jobs and industries. You could become energy independent. You can create solutions, feed people, help the world type thing. It's a limitless future, limitless possibilities. Let's say something is true, but you don't try. You fail at life. If something's true and you don't try, you lose everything and you gain nothing. If something is not true and you try anyway, you still might discover something revolutionary, you might create jobs and industries, you might become energy independent, and still create solutions and help people. You can teach people the right way of doing something if you discover that what you're looking into isn't true. But if something is not true and you don't try, you lose nothing and gain nothing. So you can eliminate 2 realities just by trying to do something. Look on that scale and see how much benefit is there of one side or the other if you try versus not try. You could really discover something and open the world up. And another quote, one of my favorites, "Scientists of today substitute mathematics for experiment and wander through equation after equation until building a structure which has no relation to reality." So when it comes to the concept and the claim of magnetic waves, that's a reality. And we are exploring that new branch of science. This is a picture of Fernando Morris. He's an electrical engineer, worked with IBM for many years, is a satellite communications and troubleshooter. Extraordinary claims require extraordinary evidence. But acquiring extraordinary evidence sometimes requires an extraordinary approach. How can you expect to find something extraordinary if you're using ordinary means? What we have in San Diego is a compilation of extraordinary evidence to support the notion of magnetic waves, which again opens a new branch of science, discovery, and application for energy generation, medical, transportation, and a lot more. Now what you see here on the right is Fernando in front of a bunch of UPS batteries, uninterrupted power supplies, and that's what's required for this type of work is major power. We need about a megawatt of power, which our current building just cannot handle. So this next slide, this is a visualization so you can get an idea of the context between the difference of regular magnets versus magnets imprinted with waveforms. Standard magnets only have one north and one south pole. The point is that there are different ways of making materials which result in different behaviors and beneficial effects. If you use an incoherent process to make a magnet, you'll reap incoherent electricity. Incoherence is heat, resistance, turbulence. The theory is that temperature we feel around us is disorganized electricity. And I liken this magnetic process to like a magnetic prism, in a sense, where the result makes for a coherent flow of electricity, but when used in a specific orientation with other materials. Magnets alone are not a power source. Magnets are not batteries, but they are a means to generate electricity. And if we focus on a different way, there are more beneficial and clean ways to generate electricity, which don't result in radiation and everything that we are used to now. Now, wouldn't it be revolutionary if we didn't need to waste millions of dollars pouring liquid nitrogen on magnets to make them levitate? Everybody loves levitating. Everybody loves the hoverboards, and everybody wants to fly. What if there is a way to lower the temperature just as a byproduct of drawing a load to generate electricity? When you increase a load, draw more energy, normal systems heat up, they create more resistance, and the energy itself is analogous to like white snow on your television or static on the TV. That's like Brownian motion. And what you see in the upper left pictures is a magnet levitating over a superconductor. That's called flux pinning. Everybody loves these experiments. But in all of these experiments, they have to pour liquid nitrogen or use helium, and that's what they're doing at CERN. And it's very expensive to try to keep something levitating or keep something cold. But what if there was a way to make a magnet which resulted in cold? That would make something coherent, because incoherence is disorganized, incoherence is heat. But coherence, all of that energy is still present, but not turbulent. And this concept is very important for people to understand. And here is a little graphic by NASA. What is ordinary light and what is a laser light? And you can see that ordinary light, sunlight, incandescent light is varying frequencies, disorganized, varying wavelengths, out of phase. But when you have a laser beam, everything is focused and collimated. Now you have a flashlight, makes light into a cone, but you have a laser beam, it's really focused beam in a specific color. Laser beam is like a sine wave of light. Now what if you make a geometric array of physical ridges equal to a given wavelength of light, like a morpho butterfly wing? When you look at the morpho butterfly, it has these little physical ridges, and they equal a specific wavelength. It's not pigmented, it's not a dye, it's just the physical geometric structure of the wing itself, and when you look at it, it looks metallic blue. But what if you can imprint an electric signature into a material which can mimic that type of behavior. So it guides energy in a different way. So pouring liquid nitrogen in an attempt to force cool a system is like watching the static on your TV in slow motion. Reducing the incoherence, reducing the speed of the incoherence present is not the same as generating coherence. So chaos in slow motion does not equal order. We are ultimately after a coherent electric field, coherent electric currents. This revolutionary magnetization process that I'm talking about with magnetic waves is a means to achieve that inevitable goal. Coherence of mind and coherence of the very electricity we use. There are major similarities between light, electricity, and magnetism. They're all related. In this little excerpt called Light as Air, that was taken from an article about Eric Lathwaite, who is the father of the maglev train. And many people don't know that his other work, not just with magnets, he liked to work with photonics and crystals and the geometric array on butterfly wings and on bugs. He was fascinated by that and how it related to magnetism and electricity. Now this next slide, speaking of the maglev train and more levitation, this is called eddy current repulsion, diamagnetism. Usually a menace in electrical engineering applications, but with magnetic waves, we could use these forces to our advantage for frictionless magnetic bearings. What you see here is a large spinning copper ring underneath this strong neodymium magnet. The motion of the copper alone generates these eddy currents, which repels magnets. So the magnet will hover if you put it over this rotating copper. There's no magnets in the copper, it's just rotating mass of copper. So if you have this magnet over the copper, it will levitate, but it won't spin. If you have that magnet 90 degrees, it'll want to spin, but it won't hover. So wouldn't it be revolutionary to imprint a coherent frequency into a material which generates a wave? What would happen to that material? It would levitate and spin, something that normal magnets do not do. It's one or the other. And that is something very highly sought in superconducting research. If you could make something levitate and spin, that's like a holy grail of magnetic research. Frictionless. Here are some contrasts between uniform and random technologies. So people can pause the screen and take a screenshot of that. On the left we have these images on an oscilloscope, not of an electric wave, but this is of a magnetic wave, of a rotating ring with a Gauss meter, and you see this magnetic signature on it. In more examples of this, really it's an electric signature which displays and manifests as a magnetic waveform when the material is spun. And what you see here on this green film is an exaggerated version of this true waveform imprinted onto this material. And Fernando Morris discovered this way to duplicate these magnetic waveforms. Now, this is a new branch of science of programming waveforms into magnetic materials. There is no literature. You can't research this. It's something that is unique to our facility. You can't outsource it. It's something that only we seem to be focusing on. You can't purchase these magnets from a Chinese manufacturer. These are a unique blend of materials. This is not something that you buy from China or you can just get off of your refrigerator. These are uniquely made magnets. And these magnetic waveforms lead to this inevitable reality of a limitless future in energy with these coherent electric fields. I personally spent 8 full months discovering a way to make these new magnets from ingot, from the raw materials. They're very special and they're one-of-a-kind magnets. These magnets, you can machine them. They're machinable. Like they're You can drill through them, you can shave them down, you don't need any oil or water, you can take any type of drill. It's something you cannot do with any other magnets. Not only that, but you can take the shavings and the leftovers and you can press them back into another magnet. You can reuse it again. Something else you cannot do with any other material. You can also measure a resistance across the magnet. So normal magnets, if you take a ceramic magnet or an alnico magnet or something, you put a voltmeter to it, it'll just short out. Beep! It won't show anything. Or you take another type of ceramic magnet, it won't do anything. There'll be nothing. It'll either short out or you get nothing. But with these magnets, you can actually measure a few hundred ohms resistance in them. So it's different. You can also rub them and get a static electric charge in addition to the magnetic field. Just a very different material. Now, anyone who's interested in more about these magnetic waveforms, please take a look at this video I put together called Magnetic Waves, Coherence, BEC, Geometric Structure, and Casimir Force. It's about a 45-minute video, and it'll give you a lot of context with a lot more hands-on demonstrations of what I'm talking about. Because again, this is a very new topic and a very technical topic, and I can't cover it all in this one talk or even mention all of it. So a lot of what I'm showing you is just to show you that it indeed exists and for you to further investigate the information from the information in the slides. So lurking on these magnetic waveforms, again, got the attention of my friend Russ Grease of RWG Research and Isaiah Ritchie, who goes by Wood, Brass, and Glass on YouTube. And they had some extremely unique ideas on trying to duplicate these magnetic waveforms that are made with an actual electric signature. They're trying to duplicate it so they are cutting pieces of metal, and then they put the cut metal on put it together, and then when they energize it, the lines will match the cut pieces of metal. So you actually get a waveform when you roll the magnet, and they have examples of that, and I thought that was extremely unique. But still, it's a conventional process using the same 60 hertz or same unregulated, unmodulated currents. And this is what we're after. So if we had proper funding and support, we could hire these types of independent researchers, and that's our goal, is to have a few personnel and about a megawatt worth of energy to use on this project, so that we could make these magnets and make them large and prove out more of these claims and show and display their benefit and apply them. We are ready to create jobs. We're ready to offer discovery in unexplored areas of magnetic science. The core technology behind the magnetic waveforms is called the Searle effect, which enables natural ambient sources of energy to be converted into useful electric power. The manufacturer's prototype we are aiming to build requires 1 to 3 megawatts, say 1, and in a UPS, an uninterrupted power supply. That type of power our current building can't provide. It's just way too much. Blow every fuse in the place. While all of the Brunos, as we're talking about earlier, Pablo and Bruno, while all the Brunos of the world work hard following their ordinary processes, which reap an ordinary linear result, we in San Diego, California are working smart on a nonlinear solution, like Paul from the parable of the pipeline. This newly accepted branch of science is based on magnetic fields that produce radial electric currents. Under certain conditions, a unique gravitomagnetic force can also be generated, without the need for liquid nitrogen. Electricity can be produced as pulsed DC or AC, hence can be utilized to supply power to existing electrical grids, or supply it on a decentralized basis, driving electric motors for cars and ships. And that's the point, is that we do not need gasoline or oil or nuclear, coal or even solar panels. we could use these magnetic waveforms in a specific setup to harness the energy that is already around us, still abiding by laws of thermodynamics, and just harness energy in a different, smarter way. That we don't have to use a shovel full of coal will give us this much of energy for this long. No, we don't need to live like that anymore. We have different ways which we can sit back and harness energy the smart way. And this is an example of the magnetic ring in a material that was just 2 weeks ago made and imprinted with this electric signature that we can test on these platforms, which is like a dynamo. Like when you get your smog check, it makes your wheels turn. Same thing here. You make this ring turn, and we test the magnetism in it and the Gauss, and you can see its gradients. You can see it waves up and down. You can see its variations. Now we are trying a brand new process in San Diego with 3D printing these magnetic materials, something that I've never seen attempted before, and we have successfully tested. What you see here is a 3D printer specifically for metal, and we were able to print a ring out of alnico powder, and I was able to pulverize it and have this machine print out a ring, and it worked. So this has the potential to fully automate the preparation and magnetization processes to offer a one-of-a-kind service that you cannot seek anywhere else in the world. What we have established in San Diego is a scientific foundation to study magnetic waveforms in a testable and professional environment. This has been many years coming. After 6 years of establishing the facility in San Diego and working hard to acquire these pieces of equipment and get as far as we are today, we finally have a working test platform to imprint these magnetic waveforms onto materials and see what they can really do. So that is a major achievement at SMI in San Diego for us, is that we, again, finally have a testable platform. The amp racks are up and ready. And on a small scale, on these small rings, we are able to imprint these magnetic waveforms. So it's a phenomenon that has been validated, and we can show it and repeat it. Now, one of the last things I wanted to show is context regarding these coherent electric fields, and what's the benefit of that? Well, looking back at the structured water, that distillation process that makes that special electric bond retain in that water, in order to do so, you have to have it under a magnetic field and a coherent electric current. And that's what helps to make that state of water. So what happens? What happened with this man, Guido Ebner? He was doing electrostatic experiments in his own home, and he found that his houseplants would rather grow toward the electrostatic source more so than the sunlight in the window. Everybody knows that plants need sunlight in order to flourish and grow, but for some reason his ferns were flourishing more, growing towards his electrostatic setup and his static electric field, an SEF as he called it. Now, even stranger, he took the seeds and he, bred, let's say, that next plant of that same fern. But when he did, that next fern looked nothing like the one before. Unprecedented change in one generation, like evolution, from the same plant. And that was all while it was under the influence of this coherent static field. So he tried it with trout, and he grew some trout under this influence of static electric field. And the first generation looked like they normally do, but the second generation under the constant static electric field looked nothing like the ones before, were healthier, bigger, more vibrant, just different, majorly, noticeably, documentedly different. And rather than actually evolving, it looked more so that the plant and the fish reverted, because I read somewhere that the type of trout hadn't been seen since like 100 or a couple hundred years. Like it was an extinct species of that trout that somehow restored the original potential. And I've heard claims that this Ebner effect can reverse GMO damage in genes and foods, so you can make corn back to its original state again if you have these seeds under a static electric negative field. So imagine what we can accomplish within a generation by supporting these branches of science and the concept of coherent electric fields and magnetic waves. Not only power our homes and industries, but also restore the air, water, and quality of life for every being on the planet. Not a utopia, just a smarter way of living, while providing future generations with the clean world to inherit that they deserve. And the last thing I wanted to show, since our planet is like a giant magnet and has a magnetic field, and the sun has a magnetic field and indeed interact, for people to seriously look into suspiciousobservers.org and all of these websites, and Ben, who is going to be speaking at the next Electric Universe conference this next week, talking about the relationship between the sun and the earth, and how the sunspots and coronal discharges and everything trigger earthquakes, and how Birkeland currents interact, and how the magnetic fields on a cosmic level interact. So I hope you've enjoyed some of this information. There's a lot more to share, and I have a lot more information throughout the links. Please contact me. Again, my name is Jason Verbelli, and this talk, Our Inevitable and Limitless Future, A Magnetic Field of Dreams, is brought to you by the Global Breakthrough Energy Movement. Thank you.